A series a series pipe system consists of 10 miles of MPS 16 0.25-inch wall thickness connected to a 20 miles of MPS 14 0.25 inches wall thickness and 10 miles of MPS 12 0.25-inch wall thickness pipes. Calculate the inlet pressure required at the beginning. For a gas flow rate of 85 million standard cubic feet per day, gas is delivered to the terminus B at a delivery pressure of 600 psig. The gas gravity and the viscosities are 0.6 and 0.000008 pounds per feet seconds respectively. The gas temperature is assumed constant. So the gas temperature is assumed constant at 60 degrees Fahrenheit. Use a compressibility factor of 0.8 0.85 and the general flow equation with the Colobricks fraction factor of 0.015. The base temperature and the base pressures are 60 degrees Fahrenheit and 14.7 psig respectively. Now let's begin. Now from the given information, the first segment of pipe L1 is 10 miles and the outer diameter, which is the nominal pipe size, is 16 inches, while the thickness is the same for all, is 0.25 inches. And again, for the second segment of the pipe, you have the length to be 20 miles and the outer pipe diameter to be 14 inches. Then the thickness, the wall thickness to be the same, 0.25 inches. So now the third segment is the length of the third segment, which is L3, is 10 miles. It's 10 miles. And the outer diameter is what? 12 inches. Now we also have the wall thickness to be the same as 0.25 inches. Now we are also the volume flow rate of the gas in the pipe is 85 times 10 raised to power 6 standard cubic feet per day. Now, and the delivery pressure at B is 600 psig and the gas gravity is 0.6. The viscosity of the gas is 0.000008 pounds per feet seconds. The gas temperature is 60 degrees Fahrenheit, which is 60 plus 460, which is 520 Rankine. Now, the compressibility factor is 0.85. The Colibris friction factor is 0.015, while the base pressure is 14.7 pxia. The base temperature is 60 degrees Fahrenheit, which is the same thing as 520 degree Rankine. Now, these are the given information. Now, from this given information, we now observe that the first pipe segment L1 is 16-inch diameter. The other one L2 is 14-inch. You now have the last one, which is L3. So this is L3. Now, we need to first calculate the inner diameter, because the inner diameter is what we're going to use to solve this particular problem. So now the inner diameter 1 will now be d1 minus 2 times the wall thickness. So you have 16 minus 2 times 0.25. So this will give us what? 16 minus 0.5, which is 15.5. So D2 will be D2 minus 2 times the wall thickness, which is the same thing. The other one is 14 minus 2 times 0.25. So this will give us 13.5 inches. And D3 will now be 12 minus 2 times T, which was 12 minus 2 times 0.25. This will give us what? 11.5 inches. Now we're going this. Now, pipe in series. Now the diameters are not the same. The diameters are not the same. So what we're going to do is to find the equivalent length. Now, with this diameter like this, the first segment you have L1 D1. The second segment you have L2 D2. The third segment you have L3 D3. Now, here is your A and here is your B. Now we are asked to find the pressure, the inlet pressure, when the delivery pressure was given. So now, and when you check, the diameters are not the same. Since the diameters are not the same, the way to solve this is to make, now we can convert this from here to here to have the same diameter as this, as D1. Also this to have the same diameter as D1 with an equivalent length each of them. Now, this is how to do it. Now, since we are making use of the general Since we're making use of the general flow equation, now from the general flow equation, you have flow rate equal to 77.54 times base temperature all over base pressure times P1 square minus P2 square divided by G, that is the gas gravity, times the gas temperature times the length times the compressibility factor times the Colibris friction factor, all raised to power 0.5 times D raised to power 2.5. Now, if we look critically now, this is um the challenge we have here is pipe dimension issue. So it's a dimensional properties of the pipe. Now, in dimensional properties of the pipe, as in regards to flow, the base temperature and pressure for this gas is constant. The gas properties are constant, are not being affected. The gas coming in are not being affected. The properties of the gas are not being affected um, by the dimensional properties of the pipe. So now this one is the gas properties of the gas, which is constant. The gas gravity is the gas property is constant. The gas temperature is constant. The compressibility factor of the gas is constant. The friction factor of the gas is constant. So, but the length is not constant because we also want to calculate the equivalent length as against the densities, the diameter, sorry. So now, that means we have the whole of this, and this, except the length as constant. So we will not just lump all of them as C times, you have P1 square minus P2 square all over L, all raised to power 0.5 times D raised to power 2.5. So this is what it will now become. All of these other distance will now become a constant. Now let's go to the next page. So that means we have Q equal to C times P1 square minus P2 square all divided by L all raised to power 0.5 times D raised to power 2.5. So now if we square both sides of the equation, we have Q square equal to C square times P1 square minus P2 square all in bracket divided by L times D raised to power 5. So now that means we'll rearrange this equation. That means P1 square minus P2 square will now be equal to Q2L divided by D raised to power 5 times 1 all over C square. Now, if we now assume that k is equal to 1 all over c square, so we now finally have p1 square minus p2 square is equal to k q square l all over d raised to the power 5. So now, to calculate the equivalent length of a pipe segment, now we want to change the diameter of this pipe segment to be equal to this one. This is D1, this is D2, this is D3. So we want to change the diameter of this segment to be the same as D1, so that when we want to calculate, we're using D1 all through. Now, to change D2 to be the same as this. Now, we will now find an equivalent length of this segment that the pressure difference between here and here will be the same, but the length will be different. Now, what I'm saying is, now let's say the equivalent length let's say we have no, okay, now here is A and here is B. Let's say here now is C, D. Now pressure PC square minus PD square will now be equal to, based on this formula, let me call it equation 1. Based on equation 1 is equal to K Q square L2 divided by D2 raised to power 5. Now, I want the diameter to be the same as D1. So for me to make it D1, I will now find an equivalent length that will give me the same pressure difference. That will still give me this same pressure difference, where you have the K is constant, the flow rate is the same thing. You have now the length equivalent divided by what, D1 raised to power 5. See what? So meaning that since this and this is the same, this is the same with this one. So let's see, this and this is the same. So we'll just say K Q square L2 divided by D2 raised to power 5 equal to Q Q square LE2 divided by D1 raised to power 5. Now we cancel out these, they are the same. So they are the same. So for us to get the equivalent length, that will give us the same pressure difference between here and here. Now the equivalent length LE2 will now be D1 all over D2 raised to power 5 times L2 from here. Because from here, when we cancel out this, you have L2 all over D2 raised to power 5 equal to LE2 divided by D1 raised to power 5. So from here, if you use this to multiply this, you have this left. So that is what we did here. So we haven't gotten this. Now we can use this same thing to get the equivalent length of segment 3. So we can use this relationship. So segment 3 now, if you look at it now, let's now find a general rule. So we say equivalent length. Now we'll call this one A. A segment will be equal to the diameter we want all of them to be. The diameter we want all of them to be divided by the diameter of the segment, all raised to power 5 times the length of the segment. So now this is a general formula. So now we'll now say D1, which is what we want all of them to be, divided by D3 times L3. So the total length now using D1 all through will now be, now the total equivalent length will now be L1 plus LE2 plus LE3. Now, the reason why we didn't change the L1 remains L1 because the diameter is D1. So, but if you put D, let's say you're looking for, let me say LE1, you say D1 all over D1 raised to power 5 times L1. So you see this will cancel out. You are left with L1, which is this. So, and the L1 is what? 10 miles. Let me see, it's 10 miles. Yes, 10 miles. Plus the equivalent, you have the other one, and the diameter to be 15.5 inches divided by 13.5 inches, all raised to power 5 times 20 miles, because the L2 is 20 miles. And plus this one, you have 15.5 divided by what? 11.5, all raised to power 5 times 10 miles. Now, using calculator, using a calculator, you have the equivalent length to be 10 miles plus 15.5 divided by 13.5, all raised to power 5 times 20 miles plus 15.5 divided by 11.5, all raised to power 5 times 10 miles. This will now give us what? Now we have 10 plus bracket open 15.5 divided by 13.5 bracket close raised to power what? 5 times 20 plus bracket open 15.5 divided by 11.5 bracket close raised to power 5 times 10 equal to this now becomes 94,138 miles. Equals 94,138 miles. So now we have gotten the equivalent length. Now, having gotten the equivalent length, we now make use of our general flow equation. So now, for the general flow equation, you have Q to be equal to 77.54 times base temperature divided by base pressure times the initial the, the inlet pressure, which is pressure at A square, minus pressure delivery pressure, which is pressure at B square, divided by G, which is the gas gravity, divided by the gas temperature times the equivalent length times the compressibility factor times the friction factor, all raised to power 0.5 times the pipe diameter, which is D1, because we have converted all the diameters to D1 by calculating the equivalent length of each of those segments. So now, where Q is what? The volume flow rate. This is what we call the volume flow rate of the gas, which is in standard cubic feet per day. Now we have the TB, which is the base temperature. We have the PB, which is the what? The base pressure. So the base temperature is in Rankine. The base pressure is in PSIA. Now we have the pressure A, which is the upstream pressure, or the inlet pressure, and this should also be in PSIA. Now you have the PB, which is what? This downstream pressure, the outlet pressure, which is PSIA, or you call it delivery pressure. So that is it. So now you have the G, which is the gas gravity. It's dimensionless. So you also have the gas temperature. As the temperature of the fluid, that is why they make it F. So it's in Rankine. You have the length of the pipe segment, which is what? It's in miles. Unit is in miles. The length of the pipe segment, the unit is in miles. Then you have the Z, which is the compressibility factor. you have F, which is the friction factor. See, which is the friction factor. Then you have D1, which is what? The diameter of the pipe. This is in inches. So that is it. So now this is the formula we're going to use now. We're going to use now to calculate for the delivery pressure, the inlet pressure. So now we have Q equal to 77.54 times the base temperature divided by the base pressure times P1 square minus P2 square divided by, so P1 is P at A, then P2 is P at B, so over G times this times Z times LE times what? Compressibility for to divide all raised to power 0.5 times D1 raised to power 2.5. So now we have the flow rate to be what? Flow rate is our 85 times 10 raised to power 6 equal to 77.54 times the temperature, the base temperature is 520, the base pressure is 14.7, now times bracket open, the inlet pressure is what we're looking for, minus, now minus, this is the pressure at B, which is the delivery pressure, which is 600 psi G. Now I want to convert this psi G to psi A, because in our calculation you use psi A, so we now add, it will now be 600 plus 14.7. This will give us 614.7 psi A. So you have this to be 614.7 psi A. So that is what we're going to use here. So it's 614.7 square divided by the G is 0.6. The gas pressure, the temperature is 520, which is this. The compressibility factor is 0.85. The length is 94 point. 94 point what you get? 94.38. 94.38 times the compressibility factor, the friction factor, sorry, which is 0.015, all raised to power 0.5 times the internal diameter, which is 15.5, all raised to power 5. Now, for us to solve this, we divide by this, all through by this, so this will cancel out in the right hand side. So you have 85 times 10 raised to power 6 divided by 77.54. Now times, now we are dividing the whole by this. So you have on the left hand side you have 14.7 divided by 520. 14.7 times this whole thing divided by 520. So now We are also, this is dividing here. We're going to multiply both sides by this value so that we'll cancel it out here. So we have now 0.6 times 520 times 0.85 times 94.38 times 0.015 all raised to power this 0.5. Now we'll divide by this, or both side by this, so that this the whole it will go out from this side, from the right hand side. So we have 15.5 all raised to power 5. So this we're now left with only p1 square minus 614.7 square all raised to power 0.5. So we have, sorry, here we made a mistake. This is 2.5. I now wrote 5 here. So that was why the answer is not coming out. So now let's calculate. Let's calculate now. We have, let me make use of my calculator. We have 85 times 10 raised to power 6 times 14.7 divided by 77.54 divided by 520 times bracket open 0.6 times 520 times 0.85 times 94.38 times 0.015 bracket close raised to power 0.5 divided by 15.5 raised to power 2.5. So as it is now, so we have the whole of this expression to be what? To be 634.819.22797 equal to p1 square minus 614.7 square all raised to power 0.5. So if we multiply both sides by, if we square both sides, this 0.5 will go out. So we're squaring both sides. So we now have to square the right hand side. Well, this one will cancel out this. So now, because this 2 multiplying this power will give you 1. So it's only this will square now. So we square it. We have what? We have 40 0.18 is equal to p square, p1 square minus 614.7 square. So p1 square will now be equal to, if you move this to this other side, you have 614.7 square plus 402,995.7826340818. So una say plus 614.7 square equal to this. So now, so P1 square will now be equal to 780,851.872,634,018. So then the P1, which is the inlet pressure, will now be the square root of this. So which will give us what? 883 point what? 65823293512. Yes, A. So this is roughly 83.66 pxia. Now, if you minus 14.7, you have the absolute, this is the absolute pressure. You now have the gauge pressure, which is 868 point what? 96 psi. So this is the inlet pressure. This is the inlet pressure. So that is the final answer. Now, this can also be solved differently without calculating the equivalent length. You just, let's say this is the first section, this is the second section, this is the third section. We can calculate this section by section. Now, here is given the PB. Here we're looking for A. Now, we know D3 and L3. We know this D2, L2. We know this D1, L1. So we can calculate this. This is an assignment for the viewers. So now what you're going to do is, now using the general flow equation, you are given this and this. So you have to calculate, let's say here is A, B, here is C, D. So you're calculating pressure at D from this. Now, where this one is given, you're looking for this. Now, using that same equation, now you have the flow rate is the same. You have 77.754 times TB over PB times, now you have PD square minus PD square now minus PB square divided by what? G TF Z ZF and the length 3. So raised to power 0.5 times D3 you calculated raised to power 2.5. So now, if you, this is the flow rate is the same, the length will not be this, it will just be this L3. You will use it to calculate your D. Having calculated this D, you also do the same here. This You now use the same formula, but now the L will be L2, the D2 will be, this D3 will now be changed to D2, then here will now be D, the PD. Now we are calculating PC, here will be C, PCPD. Now the whole of all these other things will remain the same, only here we change this, we change this, once we change. Use it to calculate for your C. Now for your C, you can now calculate your P1, which is what we are asked to get. So that is another method to do this without using the equivalent length. So that is it for pipes in series where you have different diameters in a series. So that is that. Thank you for watching till the end. Have a nice day.